In this video, I'm going to give a brief overview of the different types of memory there are in C. Now, when you're in a programming language like Java, you generally don't have to worry about this stuff. Basically, what happened is you create variables, you maybe use a keyword new, and stuff just worked for you, and life was good. Unfortunately, things aren't so straightforward in C, and we actually need to care about this. So memory in C is divided basically into three types. We have basically static memory, stack memory, and heap memory. Also up on the screen is something called program code. I'm not really going to count that as a type of memory though, because it's something we're not going to directly manipulate with our program. So types of memory, what is it about? Well, every time I declare a variable in my program, I need to have storage space for it somewhere, right? I can't have information being stored unless there's some actually place to put it. So it has to go in one of these three places, either static memory, heap memory, or stack memory. So these three over here that I'm highlighting, three main choices. Now what this diagram is showing is the basic layout of a program in memory. And later on, we'll actually get to this in more detail. This whole unit here, this rectangle we're looking at, is actually what's called the process control block. This thing here, I'm going to try and outline it. And what this is really a representation of your program. On your system, right, you're going to have many programs running at the same time. Each of them has this kind of isolated world to itself, right, where everything it needs is stored. Obviously, you can see on top is program code because there's no way for us to have a program running unless there's code to actually execute, right? So then in addition, though, to that, right, we have these three different regions of memory. Overall, if I kind of want to summarize these regions, static memory is for stuff that is persistent. So sometimes you have variables, or picture you have a variable in a function. That variable is only going to be around when that function is running. And when that function finishes, that variable will go away. That's not very persistent. Now, there are other variables, and this is going to be different than what you've seen maybe in Java. This is kind of a C-specific thing, something like a global variable, which is really a variable that's persistent for the duration of the program. So instead of it just vanishing when a function exits, it's actually going to be around for the entire running time of your program. So that region up here, this stuff, is dedicated to those types of variables that will be around for the lifetime of your program. The other two parts we have over here, heap and stack, are a little different. So stack, we'll actually jump down to the bottom and talk about this. So stack is the memory that's allocated when you call a function. And generally there's this idea of something called stack frame, and we'll talk about this in depth. But the idea is every time you call a function, let's say this is like a function called f, and we're going to just draw f of x here, it borrows some memory to store its local variables, or its parameters, or its return types, or whatever you have, right? Maybe f calls another function, maybe it's called g of x, and it basically requests another block of memory, and it pushes on a stack. And so as functions call themselves, there's a stack that kind of builds up with these so-called stack frames that contain information or data for each of the calls. So this is basically stuff that we can kind of know in advance, because if you think about it, it's possible for a compiler to look at a function and basically tell how many variables are created within it. And then from that, estimate what is the size of that particular function, right? How much memory is it going to need? That can be done in advance. So that's basically what your compiler is going to do. It's going to predict that and basically set this thing up so that whenever a function needs to be called, we know how much space to reserve for it. Now on the flip side, we have the heap. The heap is basically for dynamic allocations. So when we don't know in advance how big something is. So maybe we're relying on something like a user input, where the user says, oh, I want you to store this and this and that. And we don't really know that in advance. So heap is somehow for dynamic information, right? Things that we don't really know the size of in advance, and we have to wait until the program runs in order to find out how big it is, and then we have to basically go to the operating system and request a chunk of memory that's that large. So usually I draw kind of the heap as this little like cloud thing, and there's little allocations inside of it, right? So based on how much memory I need, I maybe get one of these shapes. Hopefully, right, I actually have enough memory in there to do that. So that's the three types of memory. We're going to go into each of these in depth now. So static, heap, and stack. Let's check them out.